We've done this before.
Yeah, me too.
Hey there, everybody. You guys know I am a huge fan of Paul components. I've reviewed the Paul clampers on the channel, and we are here at Paul HQ. We're going to get a tour of their headquarters from Patrick, who is the process engineer. Did I get that right?
You did.
And a little Q&A with Paul himself after the tour. All right, so take us, what you got?
So generally Paul will come up with an idea. Basically, he'll go on a bike ride, he'll think something up, and then he will either draw it in a 2D CAD program or on a piece of paper, non-complicated, and then he will either hand it to myself or Jim, who's the shop manager, and we will put it in our CAD program and make a solid model, do an assembly, and then kind of move it around, look at it, see if we need to change anything before we move on to the manufacturing. And
so this is where the Imagineering department is.
yeah, right. And then I guess I could show you some of that, screens, I don't know. So kind of proof of concept, this is what Paul will give us. 2D, we will then turn it into a solid, so we can rotate it around, get a good look at it, you know, smooth up some of the more aesthetic features. We can, you know, this is an exploded view just to kind of see what's going on inside the clamper.
How many iterations of the CAD drawing did you guys go through before you landed on kind of the final design?
I think it was about 4
Okay.
or 5. It was about 3 or 4 years before we actually put it into production for sale. So it took, you know, it takes time to get this stuff right. And
What was the biggest design challenge?
I think getting the helix angle of the ramp and material for the pistons, as well as the angle for the arm and getting all the leverage, you know, mechanical advantage figured out and done correctly. Yeah, so there's 7 components in the assembly. And basically, as you see these little ramps here, I'm actually making these downstairs right now, but as you pull the arm, there are ramps on both of these pistons, and there's ball bearings that ride up those ramps, and that's what actually actuates the piston. It's a very simple mechanical design used throughout the industry, but it's very robust. We use a slightly larger ball than I think the other non-named competitor. The body is very, you know, let's say robust, and that allows it to, you know, stay cool and be rigid throughout a braking cycle.
Thick, with 2 C's.
Yeah. So it's all machined in-house, you know, minus the hardware. We don't make little nuts and bolts, but we make everything else here. So from the CAD stuff, we can go ahead and start programming, and I didn't open my software before you got here. It takes a moment. CAD stands for computer-aided design, so that allows us to kind of figure out the design before we start making something. And then we put it into our CAM package, which stands for computer-aided manufacturing. And so we use Mastercam, as you can see loading up here. And this allows us to assign tool paths that the machine, and then post code that the machine can read. So we can physically make it like in the computer and then post code out, send it downstairs, and it'll pretty much do what we see on the screen. And then we have to, you know, prove it out and cut jaws and figure out how to hold all these different things. So this is the piston that's inside the clamper. This is one of the parts. This machine, it has 2 spindles, so we have a left and a right spindle, and we can feed bar stock in, and basically the other spindle will come over, grab that part it off, and then we can finish it on the right spindle. So we'll get one of these parts off finished in an automated fashion.
So do you have to tweak the code much after it gets spit out from the CAD software, or is it pretty much like one and done?
Yeah, this will get you 80 to 90% there.
Okay.
I could spend more time working on my post processor, which is what actually translates this to G-code, like the toolpath I assigned. But I do a little bit of finger cam down there to kind of fine tune it and get it to run well in the way we need it to.
So the whole process is kind of like a subtractive process, right? From like a bill of material. So you have to, that's kind of one of the design constraints is like, okay, how can we cut things out from a single piece?
I only have so many axes to work with, so I can't, you know, angled holes can be a little bit challenging, but for the most part, this machine will do pretty much everything. Before we used to make it on the lathe, so it would have like work in progress. It'd sit on a shelf, and then we put it on a mill to do the other features. So it'd have multiple operations. Someone had to handle it. Someone had to hand load each of the mill runs. Whereas this, I can just load bars, which I'll show you later,
Yeah.
in a magazine bar feeder, and it'll run all night.
What part of the process does this get involved?
Well, it was my birthday, and apparently this is my birthday present.
Do you play? Seriously? No.
I do play the drums, but not super seriously.
So we've got the code, and then we're going to go to the actual manufacturing.
So this is the shop. We have one machine that's still belt dry. That's why it kind of winds down here. But we have 4 mills and one lathe and a mill turn, which is a lathe and a mill kind of combined into one. It's not very exciting because the coolant's always on hitting the door. You can take a quick moment here and have a look inside. So this is our newest machine. This thing has really helped us get parts out the door and do it in a much more timely fashion. It takes longer to set up and program, but as you can see, this is what the bar stock looks like coming in. So this is op 1 basically. It can do a bunch of work on there. And actually just did a part off, so then it would come over here. This would come over, grab the part it off with the part off tool, and then this will get more features milled and or turned. So these are all live driven tools. So this is like having a mill as well as a lathe in one machine. And it's basically like having 2 of them because it has 2 spindles, so you can work on, you know, the front and back spindle, as well as having driven tools for both the front and the back. So this will run overnight, lights out, keep cooling in it. It's got a magazine bar feeder back here, so we can load 20, 30 bars. So the parts actually come out over here, and then we stack them up. They come out in this bucket right here. So it basically goes from, you know, a 4-foot version of this into, you know, 98 of these.
Okay.
And so these are the pad piston that go in the clamper. From here, they're going to go to heat treat, case harden. Yeah, so before we'd have to spit the lathe bits off, and then we'd have to mill these on 2 different operations, 2 different machines, a lot of handling, takes much longer.
Yeah.
Now we can set this up, run a bunch of one. Holy moly. Yeah, it made 800 parts while I was gone over the weekend, so
Nice.
that's great news.
Yeah.
We also have traditional mills. A lot of our mills have rotary tooling, so we have a 4th axis. So you have your traditional X, Y, Z. So you have X, Y, and Z, and then the 4th axis rotates about X, which would make it an A axis. That allows us to basically just increase the amount of work pieces we can put in the machine, and makes the spindles run longer, makes more parts come off. Operators get a little break, and everybody's happy. Making another clamper part over here, so we're making short pull clamper actuator arms. So a lot of what we're making right now is just clamper parts.
Yeah.
It's a complicated assembly. People want them.
Yeah.
We want to get them to them.
Of Russian tanks.
So this is tooling. So basically everything we make in house, we have to have a way to hold it. So it's, you know, it's not just it starts as a block, a rectangle, a round, but then gets cut into a shape, and you have to be able to hold that shape to do the rest of the material removal. So these are all the different parts we make. Every part has a jaw box, and in the jaw box has the jaws to hold those parts, and or maybe sometimes tooling. This is kind of our pre-stage material cutting, some inspection, spare workstation. Material comes in through the door. We can show you outside on the rack. We get all our material back there. It's all USA milled, mostly aluminum. It gets cut up on this. It's a very important piece of equipment because if we can't cut work pieces, we can't run them. We can't run parts. So saw and air compressor are probably the 2 most important things in the shop, because if those go down, we have, you know, $1 million of equipment that we can't use.
Can you show really quickly how some tooling works? Like, what do you mean when it holds like a piece?
For sure. Let's do something that we make still. Okay, we've had to thin our product line down. So we have a plug gauge in here. This is for checking tolerances. We have some setup pieces in the box. So these are our love levers, compact love levers. It starts off as a block of material, 1x2, and then this is cut out of that. But you know, you got to hold on to it. There's going to be some material left after op 1. You got to get it to this. So how do you do that? We make our own soft jaws. So we actually make the jaws, and then we have a bunch of these, and then we cut out whatever shape we need, and I picked the left. So this will go into here, and this of course will be in the machine, bolted in a vise that you can tighten. And then that allows us to deck off all this stuff, and then that would leave you with this, and you got basically a finished good. We do some hand deburring, goes to our tumbling room for media finishing. As you can see, we have a lot of these, and that's, you know, it's a necessity to do this, and it does take time. Try to make this tooling as nice as possible, especially because the operators are going to be handling it so much, and you know, you don't want stuff sticking in the jaws, and
Yeah.
you want to make sure everyone's happy.
So you guys have CAD not only for like the finished product, but probably the tooling as well? Like,
Yeah, we do.
How often do you have to, you know, recreate a piece of tooling?
Not super often. On some of the high run stuff, I mean, right now our typical runs are 2,000 on the mill, which is fairly high. I couldn't give you like a general ballpark.
Right.
Usually what happens is a tool gets dull, throws a workpiece,
Yeah.
that'll bend the jaws. They are aluminum jaws, so
Yeah.
they're not hard. This is also technically tooling, so
Okay.
this is how we pre-stage every job. So when the part quantity is getting close on the machine to get to the next job, the operator will pull his setup sheet, has all of his tools, all of his work offsets, and everything he needs to load in the machine for the next job. They will go ahead and grab whatever tool is needed for the next job, and they'll put it in the order that is needed in these tool cribs. That basically just kind of, as soon as that job's done, we can pull the tools, throw these in, grab your jaws, hopefully material's cut by then, and you're off to the races. New air compressor, very happy. This is our material rack. This is kind of receiving for material. We have quite a bit in stock right now. Material prices have been skyrocketing in the last year and a half, 2 years. It's been somewhat difficult, but I haven't had too much of an issue with it. We have a really good supplier. Shout out to EMJ. They've worked with us. You know, they worked with me over the 9 years I've been ordering from them, and we're really happy. 2024 2-inch square is for the box cars, and that has been a little bit difficult just because EMJ doesn't buy that much, so we're kind of on average buying everything they buy from the mill, which is where they extrude it. We're buying 2,000 pounds at a time right now.
Oh, dang.
And it's pretty expensive, but part of doing business, you know, we got to get the parts out the door.
What here is used to make the clamper?
1.5 by 2, those are going to be for the clamper bodies. So we're doing flat mount bodies next on that machine that was doing the arms.
Right.
So we'll be doing bodies on that machine next. That stuff's for that. Clamper arms are out of the 1.25 by 1, which I think is down here. These are actually becoming the pistons that are
okay.
we saw on the Doosan. These are going to become Motolite arms. These are also going to become Motolite arms. These became seat posts. These were pad adjusters, which we ran before the pistons. Cantilevers, Neo Retros, a few other products. Those, I believe that would be for the actuator arms. So we have a bunch of that. We're actually getting low because I think the job's almost done. It's really running really fast.
This is so cool to see. Like, I mean, if
Yeah.
you just walked by, you wouldn't think that these would become bike parts. It's just like, you know, rods and,
Yeah.
and kind of beams of metal.
Right. It's impressive. One bar of this is probably like 80 actuator arms.
Oh, dang.
And then one bar of the, 1.5 by 2, I think is 35 bodies, some of that. Don't quote me on that.
How big is like a typical work piece? Like once you get the raw material, you got to cut it down so it fits in the machine. Like what's,
Right.
Is it like this long?
It
where you-
depends on the part.
Yeah.
I mean, if you have a Neo Retro, it's going to be, usually we leave 50 thou per side for cleanup, so
Yeah.
100 thou longer than whatever the kind of overall length would be.
Yeah.
So usually 2 to 4 inches, kind of depending on what we're making.
Okay.
So we kind of went from CAD straight into the manufacturing, back to the material. The life of a product, this comes through the door, goes through the saw room, which we just saw, hits the machine shop floor, and then, gets set up, runs through the machine. Then it's going to go to tumbling, and we can go see that now that we do this. Maybe we can go back through the shop,
Yeah, let's go
check
back.
out the other side. So we have 2 more mills on this back half. Currently making clampers, or I keep saying that, boxcars. 0 by 90s are up right now. So fuel that to that.
Oh yeah.
That's a pretty big
that's
amount of
significant.
material. Yeah, so
Wow.
it's a lot of material coming off, but it all gets recycled. This is another just 2-axis lathe. It has a 12-foot bar feeder on it. So this allows us to load a full bar as they come off the truck. You saw out there, load it into this bar feeder. This thing will run automated, and like the other, the Doosan, we basically spit off parts that come off on a little conveyor. And these are love lever bushings or cantilever bushings that we press into the perch to allow us to put the lever on it. So as the parts are coming off the machine, they land here, and we do track them. So once they get here, we count them. They will go into the tumbling room, and then when they get back upstairs after finishing, we count them again. Basically, it's just a way for us to track where things are in the shop. We're making a lot right now, so it's hard to know. These are actually all pistons that came off this machine over the weekend. There's a full box of actuator arms, box cart. We just did a run of Neos, so if you're waiting on Neos, that should be coming up soon. And then just kind of miscellaneous stuff, a bunch of groovy barrels.
Do you guys work on multiple products at the same time, or do you say this week we're just doing stems, this week we're just doing brake levers?
Typically, we'll make what needs to be made. Some products have so many different parts in it. We do try to match those and try to run them around the same time. The stem's a standalone job, so we'll get a body and a faceplate, or a body and two faceplates or two bodies, kind of depending on what we're doing. But once that job goes up, it's a complicated setup. We'll typically let it run.
Yeah.
So it'll run for half the year.
Yeah.
And that machine's only going to do that. So from here, we go out here. New height gauge.
Clear.
We're going to do a little tour in here if that's okay.
Oh, yeah.
So this is tumbling, media finishing, and just kind of the last step in manufacturing before it goes upstairs and gets out of my hands.
Mm-hmm.
So behind us we have two vibratory tumblers. Basically, it's a ceramic, plastic kind of matrix media that will basically take a machined part.
Do you use different types of media for different components, or is it pretty much the same?
Pretty much just those, yeah.
Yeah.
So basically, they land on this shelf. Our person will do the tumbling. Not everything gets tumbled, most everything gets tumbled. So when they go through there, they hit the ultrasonic, which is heated, and then it just uses sound waves to clean off any, it does make a small residue, so it cleans off that. Gets dried in these dryers. There's a fan underneath that blows them. Watermarks are really bad for anodizing, so we have to make sure they're really clean before they go to anodizing. And then if we do any polishing, which we do, some stuff is polished, like the barrel adjusters and spring nuts are polished. Most everything else is just tumbled and then anode. And then we do have the TED polish, which is a hand mechanical polish, and that's TED. TED does that. And this is basically corn cob impregnated wax. And so these will vibrate, and it makes them mirror.
So corn cob isn't like corn as in the growing vegetable?
Like we eat it. Yeah.
Oh wow.
Yeah,
That's
so it's
cool.
ground up corn cob. We used to use walnut, but I think this was a little bit cheaper and it seems to work a little better. So
Yeah. I mean, there's got to be some material loss in the process, but not significant enough that
it mostly just kind of mats the surface and breaks any edges. We break pretty much every edge on the machine anyway,
Right.
or by hand. So it's not going to affect any tight tolerance. Usually that's kind of on the ano side when they etch it too long. But most of those are either on a bore or an OD, and tumbling's just not going to get in there and do that. But
How long is the whole tumbling process?
it's been a long time since I've done it, but I think when I was doing it, it was about an hour in the tumbler. 30 seconds in there, dry for however long that takes, depending on summer or not, and then basically stack them back up and they go upstairs. Another big tumbler, another big polisher, basically in the corner, and this is
How many components do you stick in the tumbler at any given time?
I think in the big one, this one wasn't here when I was doing it, but 150.
Oh, dang.
Yeah,
Okay.
it's like half a run of brakes.
Yeah.
One side.
And you have to make sure to pull them all out. It's
Yeah,
not
yeah,
not
or
like
they-
losing socks in the laundry.
Right. Yeah. Otherwise, you have a very tumbled part at the end of the day, and get counted in and go to ano, and that's probably where I'll leave you. But we can go take a look really quick. And there's Paul.
Okay.
Parts come in. They land here into Miles's world back there. So we have a lot of stuff on the shelves, either going to ano, waiting to be checked in. So these noodles just came out of the polisher, and that's kind of.
Okay.
So these don't get tumbled. I think they just get straight polished. So that's kind of what that would look like, versus this is what a tumbled finish would look like. So it's just kind of mats it, make it more uniform, kind of softens the edges, as you will. So that's tumbled, and that's as machined
Okay.
versus polished. So you can kind of see all the raw stock back here. That's either coming in, going out.
How many employees touch a product from start to finish?
Yeah, that's a good question. I'd say probably most everyone here. So 10.
That seems like a lot. It passes through a lot of hands before it gets to the consumer.
Yeah, and I didn't go over assembly. I mean, I'm just kind of taking you from my domain into the an inventory and assembly. Once it hits up here, multiple people will touch it as well. So it has to get, goes out to ano, comes back, gets inspected again, gets put through assembly. There's a lot of kind of pre-assembly steps for a lot of these products. So they'll get pins pressed in them, bearings pressed in them, and then they'll get handed off to another person to actually do the final assembly. And then they get inspected again, and they go in a box, and they get shipped by another person. So It's pretty much most of the company, minus, the shop manager and office manager. It's most everyone here.
I mean, I feel like some people get the impression that, you just hit a machine, parts pop out, and then you put it in the box and ship it out. But it's actually a lot.
There's a lot, yeah, there's a lot that happens before that step too. So the clamper was years in the making before we even got to a point where we can consider selling it. I mean, that's kind of the upfront cost that, we have to take on to get there, as well as it takes a lot of time to put one of those together and,
Right.
make it right. So
In terms of like manufacturing, if are there any other machines that you wish you could acquire that would optimize the process, or
these are good questions. Yeah, sure. I mean, horizontal someday would be nice. Probably another live tooled mill turn type situation. I mean, I would love to have like 4 lathes and 5 more mills or something, but we're doing the best we can with what we got. So we're running pretty much 7 days a week down in the shop, and we're here in the office 5 days a week. So, and we have several people working 410s, so we have shifts overlapping. We're running 2 shifts basically in the shop. Kind of the same deal up here. So, yeah, we're moving, and we're trying to keep up. But
do you feel like you've maxed out what you can optimize in the process so far?
it's it's ongoing. Quality is always an ongoing process, and maximizing and being more efficient is always ongoing. So as you make something longer, you kind of see, you're like, why did I do it like that? Well, why don't we do it like this? Or the operator will come up and be like, hey, why don't we do it like this? And you're like, yeah, you're down there, you see it every day. So they give us tips, and we'll, we try to be responsive to that, and kind of just keep moving forward.
Well, sweet. Thank you, Patrick, for the tour, and I think we'll chat with Paul himself. Thank you for opening up the factory floor for us to give a tour.
Yeah, absolutely. Anytime, no problem.
So you talked with Patrick a little bit about the clampers. That's probably the product that I'm most familiar with. When you guys were designing it, he said it took 3 or 4 years. Like, what were some of the issues you were running into that you had to sort out before bringing it to market?
I tried a whole bunch of ideas I've had, and a lot of them were super wacky. We went through a whole bunch of designs. I just had to get it out of my system. Like, let's try this crazy thing. Mm-hmm. And it didn't work, and I'm sure it had been tried before, but I had to do it.
Yeah.
So that took a year, and then just fine-tuning the design just over and over and over. It was the project we are all most proud of.
Yeah, I mean, it's a beautiful piece. It works great. It seems like one of those products where it looks so simple, but there's got, like the backstory of like how it was designed, and like just seeing the process it goes through is pretty incredible.
Yeah. Well, we make them by the hundreds instead of the tens of thousands, so everything is much more precise, which the price reflects. But just the level of machining, it can be a simple thing, but if everything fits together really nice, it makes a huge difference.
Mm-hmm. I think I remember seeing a video on your YouTube channel where you disassembled it, and I was actually surprised at how kind of few parts there were.
Yeah.
It almost seems like a haiku in a way.
yeah, that's a good way to put it. There's just, there's some key things that we had to really focus in on and just get super high quality, like the roller bearing that's in there. We had to get steel hardened, and the parts, there's not a lot of parts, but each part is really refined down to.
So COVID and supply chain has been crazy times for the bike industry. How has it affected you guys?
Well, the first month was just pure panic, like everyone. I bought this Sprinter, this 4x4 that was going to be combo, me driving to events, and I get to go camp on the way. And I bought that, I think, in December of 2019. And then all of a sudden COVID, and I'm like,
oh no, all that money.
I gotta turn that thing in. They're not gonna retake it. How am I gonna, it's like the world's collapsing. And then we just were like, okay, let's all go home and hang out for 2 weeks, which we did. And then we had one gal just sort of manning the phone, and she calls up and she's just like, people want bike parts and they want them now. I don't know what's going on. It's like, we need to get going, but everybody's freaked out about breathing. And so, but she had a boyfriend, Patrick.
Yeah.
Still has a boyfriend, Patrick. And so the two of them worked for a couple months just alone. Then when it was time to bring people back, this is going to be a little long-winded. It's like I put in 3 sinks. Like everybody had their own bathroom, their own toilet, their own sink, and their own area, like 10 by 10, 15 by 15 area. We went like from panic to like just go all in.
Right.
Everybody masks. We were super safe. Now we're a little more relaxed because everybody knows more about it. But yeah, it's been a crazy ride. And the best thing is the bike world freaking won. For once, first time ever, we won that battle, and that's been so awesome.
Yeah.
Not battle, we just somehow came out on top.
Yeah.
Or I don't know.
It wasn't like the absolute doom and despair that people were expecting.
No.
Do you have any theories on as to why business fared fairly well during COVID?
Everybody's, stuck in their house. They walk out to their garage because they're just like, well, go out here, I'll get another beer out of the beer fridge. And no, that thing's hanging from the ceiling. I'm super bored. I really want to go somewhere.
Right.
Yeah, I think there was a lot of that.
With the supply chain issues, there seems like this kind of an inflection point where there might be opportunity to bring more manufacturing back into the U.S. You feel like that's a thing that could happen?
I don't know.
Yeah.
Maybe this time. It's been talked about a lot in the past whenever there's some kind of crisis, but it always goes back to China.
Yeah.
But I feel like we've seen quite a bit more interest in manufacturing here.
I know you're probably tired of this question, but when you get asked, why do your parts cost so much? Like, what is your response?
Well,
The non-grumpy answer.
no, it's not grumpy at all.
Yeah.
It's we use American material, which is always a little bit more. Material has gone through the roof. It's not a huge proportion of the cost, but it has gone up. Wages have gone up a bit, and I have the best people here, and I have to keep them. So we have to do incentives or benefits or somehow, and that costs money. The other thing is they're really, really, really good, and they will last forever. What I always say is it hurts up front, and it's all smiles after that. You buy a cheap part, it's like, oh, yay. But a year later, it's just, oh, I got to fix that now. Oh, that's wearing out. Oh, I got to fix that. So like you pay in the end. You frown when you buy our parts because it empties your bank account, but it's for the rest of your life, hopefully smiling.
So walking through with Patrick, it looks like manufacturing is pretty maxed out. How do you balance your time between developing new product and just kind of meeting demand?
Yeah. Well, another thing with COVID is we had a couple of products that are really exciting that we're just can't do that.
Yep.
I've worked on some new stuff. None of us have worked on much. Basically, it's been buying machinery, setting up the shop more, trying to get more efficient with just getting things out the door. And my job has been, let's keep the building up to date, and I've had to add on overhangs, put in new machinery and rewire things, and a lot of air compressor lines going over all the place. And we're working, like some machines are going 24 hours a day and stuff just breaks. So a lot of my R&D time turned into, I'm Schneider, the maintenance guy. Really, it's really what I own the building too. So I have a real interest in keeping it decent. We did get one product. It's absolutely ready. We just need the capacity.
Yeah.
I don't know if Patrick told you, but we're adding 2,300 square feet on.
Oh, dang.
As soon as I get a permit, which I'm very close to getting. So that's exciting.
How long have you owned the building and the property?
About 10 years.
Okay.
Yeah. And we've added on 4 times now. This is where the building used to end, and this was a loading dock, and right where we're standing was railroad tracks.
Oh, wow.
Yeah, and so they take barrels of, this was an oil petroleum distributorship, and put them in there. That was the warehouse, and that's why this is raised, because it had to be the height of a railroad car.
Right.
And then in back is a bike path, and that used to be the main train line, and then there was a spur that came off here. I'm a train guy, so it's kind of exciting. But yeah, we've had to add on, and this building was built in the 20s, and whenever you add on to something that was built without any knowledge of what we have now, it's a challenge.
So what does the future of Paul look like?
As far as new product stuff, there's just no shortage of fun things and ideas to try out for me. So we're going to continue doing that. We're going to build what we think we can build better.
Yeah.
But yeah, there's some things in the wings that are going to be real exciting, and just hopefully keep supplying really nice bike parts.
Yeah.
Yeah.
So last question: is there a product or component that you'd personally like to see manufactured, but you don't think the market would tolerate? Or you think it's like too crazy of an idea that people are like, what?
Yeah, I've been working on this product for like 20 years, and I will show it to you. Hang on a second. It's just kind of wacky.
Yeah, we like wacky on the channel.
So one of the things right now that's been a frustrating thing for me, my almost entire bike career, is small multi-tool that does not fall apart and you cannot lose the parts.
Right.
And I think the bike industry just is not ready for that yet.
Yeah.
But right here,
And
this is the future. Travis is gonna get mad at me. He thinks everybody thinks this is ridiculous, but this is it. Well, this is a prototype. It's extremely rough.
right.
But these are all the bits that
Yeah.
when you're bonked out and you're in the mountains and you take it out of your pack and they fall in the dust.
Right.
And
I've
or
had some multi-tools like
Yes.
unscrew over time, and it just happens with every multi-tool at some point.
yeah, and that's what got it going was the thing unscrewing. Like
Yeah.
3 in a row in Downeyville, and I'm just like in the mountains and far away and tired. And just like, where is that thing?
Yeah.
But I'm just, this is my personal
Nice.
fun. It's called the Unitool.
Nice.
So we're gonna do the latest version here pretty
Yeah.
soon. Maybe even sell them. We'll see.
I like how functional it is.
Yes, you can't lose it. It's just, and it's thin. You just put it in your pocket. It needs some kind of chain breaker.
Yep. Yeah.
Maybe a separate thing, but I just want to keep parts to a minimum.
Paul, thank you so much for opening up the factory and your
Absolutely.
time.
You're welcome.
If you guys enjoyed this video, like, share, subscribe. You guys have a YouTube channel, some stuff going on there.
Yep.
They're on the gram. If you guys have any questions, Paul wouldn't answer them. Hopefully, like, share, subscribe, all that good stuff. And as always, keep the supple side down.